Good morning. Welcome to our webinar on Edge Devices at the Forefront of Intelligent Building Systems. I'm Mark Peacock, Vice President of Marketing at Link-Spring. Thank you for joining us. We'll be recording this webinar, and we'll make the recording and the appropriate slide deck available to all attendees. If you have any questions, be sure to use the chat function. If we have time at the end, we'll get to as many of those questions as we can. All right, so let's get started. Edge devices are contributing to a significant shift in the way we connect, process information, make decisions, and how we manage and operate buildings and facilities today. Edge devices are now on the front line of our buildings and adding value to our traditional building systems. When it comes to these edge devices, we are now in an era that enables us to capture data from multiple sources, make it consistent across multiple applications, and add levels of control. We are also able to go further out to that edge with devices that are smarter, more powerful, have more capacity, offer higher levels of data processing, and increase storage capabilities. And thanks to IoT, we have access to multiple places where data can be collected and processed. Devices at the edge continues to grow as processors and connectivity are embedded into a plethora of previously unconnected devices, according to a new forecast called Worldwide Embedded and Intelligent Systems from IDC. In fact, this report forecasts that intelligent edge devices will log a compound annual growth rate of 7.2% from 2016 through the end of year 2020. So what are the drivers? The formidable computer power and affordability that is now available, the capacity and storage capabilities that can be embedded into a device, real-time and analytic time requirements, analytic software companies scaling down their applications, and developing new tool sets for edge computing. Where is collecting and processing data at the edge being used? At Link-Spring, we feel it's well suited for many applications such as lighting, security cameras, temperature, vibration, energy usage and measurement, equipment monitoring, plant control, machine-to-machine, and IoT applications. As such, we are delivering new edge devices for today's buildings, energy management, machine-to-machine, and IoT environments with our Onyx, which is a portfolio of easy-to-deploy embedded hardware bridges and gateway solutions, and our recently announced Genesis Edge 100, which is a new generation of controllers combining Link-Spring's Onyx platform with the Niagara framework. So without further ado, we're going to get into telling you a little bit more about each of these products. And I have joining me several folks from our wonderful team here at Link-Spring. Joining me today are Chris Ryan, who is Director of Engineering, Travis Reno, who is in our Product and Product Management group, Derek Metchie, who is with our Technical Support group, Jim Ryan, who heads up our Training and Innovation Center, Robert Hirsch, who is our Senior VP and Chief Operating Officer. So without further ado, I'm going to go ahead and turn this over to Chris Ryan, who's going to give us a little bit of insight into the Genesis Edge 100.
Thanks, Mark. My name is Chris Ryan, and as you said, I am the Director of Engineering here at Link-Spring. And it's my pleasure today to speak with you about our Genesis Edge products. So recently, Link-Spring released the Genesis Edge 100, and what this product is it's the first in the generation to combine the Niagara framework with our own hardware, the Onyx platform. Our goal here is to help you get Niagara to the edge, to places that it normally didn't go before because of cost-prohibited nature of the platform. So when we made this decision, our goal was to take Niagara to those smaller facilities where Niagara usually priced itself out of the market. We see this a lot of times in those, whether it's fast food restaurants, small REITs, places where just the cost of Niagara prevented it from getting into the space. So by combining the power of Niagara with a limited license on our own hardware, we're able to get you into those spaces that you weren't normally able to go before. So let's talk a little bit about what is the Edge and what can it do for Genesis. And right now, the Niagara Edge product runs Niagara AX 3.8 and is compatible with most of the drivers that are available in Niagara. The key thing as integrators to know is that it's programmable with the same Niagara tools. You don't have to learn any new tools. You don't even have to learn a different way to use the existing tools. This is Niagara running on the Onyx platform, and you won't notice any differences. The next thing I wanted to speak about is that there are two license options. So again, in order to get Niagara down to those smaller jobs that we couldn't get to before, we have two limited license options. The first option limits you to 5 devices and 250 points. Our second option gives you unlimited devices, but still that 250-point limit to help keep costs down on the controller. Definitely some things that we've received feedback on our initial uses as well as initial testing of the device is we're seeing increased speed, decreased boot times, and even increased memory, which have been demanded by our customers. And again, it's a smaller footprint than the J, so you can get it into smaller cabinets, smaller areas. Just in general, we feel you'll see better performance out of the controller. What I'm showing here is just a screen capture of the platform administration screen that many of you are familiar with. Once again, this is Niagara. We're using the same Pro Builder that you're used to. And if you look at the host ID and the model number, we will see that those are unique to us. Those are the Linkspring Edge. So I just wanted to show this. This is Niagara running on our controller. And here I have two side-by-side screenshots. One comes from the Genesis Edge. You'll see that up at the top. And on the bottom, it's the Geni PC6000. So these are the exact same stations running on two different devices. You see no differences. As I said before, this is Niagara. You won't see any differences. You're just a limited license. So why? Why did we decide to put Niagara on our controllers? And what we saw were the benefits to you as our customers. First and foremost, we're going to be able to get into those markets and into those jobs that we weren't able to before. Niagara is a wonderful tool, but it can be cost prohibitive. So we were able to make Niagara more economically viable by putting it on our controller and getting those limited licenses to get the cost down. Same power as Niagara, you're going to be able to be a gateway between systems. And in general, this is going to be great whether you're using retrofit, new jobs. This is going to be able to fit into those markets. So where do we see this working? Retail, small office buildings, hotels, schools, healthcare, fast food restaurants, anything like that where Niagara normally didn't fit because it was cost prohibitive. This will fit in there. This also can work with existing systems on larger buildings. The power is that now you have Fox communication coming out of a smaller controller. So ideally, whether this is used in a small or multiple across a large implementation, this controller can be used for all of them. The next item that I wanted to talk to you about today is a product that was just released, and this is our universal input option that we've placed onto our Edge 100. What this is basically it's just a plug-in card that adds two universal inputs directly on your Edge. This gives you the ability to use just a couple points of I/O, regardless of whether or not you don't need to use a full I/O controller if all you need is a couple points of I/O. Similar to what you're used to with other I/O controllers, we support the following input types. We can do relays, 0 to 10 volts, 4 to 20 milliamps, and resistive inputs, including thermistors. One item that I would like to mention is that this is not field upgradable. The option card that's installed must be installed at the time of order. So if you need this, make sure that it's included with your order. And of course, I wanted to mention that this does count as 2 of the points on your global license limit. So of those 250 points that were mentioned before, this would count as 2 of those points. What I'm showing here is just to show you how easy it is to add these points. Just like you're used to with any other driver in Niagara, you drag the device out of the pallet, drop it into your driver's container, do a discover, and there are your UI points. In addition to the UI points, you'll notice some other metrics that we can pull. Typically, you don't need those, but if you ever want to get that data and have it in your system or have it readily available, we have that metric data in there as well.
All right, hi, I'm Jim Ryan. I'm going to be covering with you today our Onyx Modbus to BACnet bridge, kind of the first of our Onyx devices to go to market, and just a simple solution for one of these new edge device concepts that we're going to cover. So what does it do? Just what it sounds like. It's going to take those Modbus slave devices that you'd like to bring over into your BACnet network, get that data out of Modbus into BACnet. Maybe you have a predominantly BACnet system, or you're doing your controls predominantly there. It does convert both Modbus RTU and Modbus TCP. It can do those both simultaneously, in fact, and it converts them to BACnet IP devices. And we have license structures that allow either 1,000 Modbus points or 2,500 Modbus points. And these can act like 32 RTU slave devices without a repeater, or a full 246 with a repeater. And then just out of the box, it can work as 246 TCP slave devices, converting over to BACnet. So who can use it is pretty much anybody. If you need to bridge the information between these 2 networks, and you would like them to be as virtual BACnet devices that correspond to each one of your added Modbus devices, then it's ideal for your installation. The biggest advantage we're bringing to market here, besides just a really small footprint device, there's no licensing required. There's no keeping up with that, no fees with that. It's lower cost than the other current solutions on the market. And one of our key differentiators is we're not just taking the Modbus points, combining them all and spitting them out as one big BACnet device. These are individually represented on your BACnet trunk as devices. So no matter how many Modbus devices I bring over, they're mirrored as virtual devices on the BACnet side. And that really is a key differentiation. We've got a very simple web-based setup. So if you have a web browser, you have all the tools needed to actually set up the device. And it's really easy to add additional points after you get it set up. Really simple to go back and just add additional Modbus points if you need to. Configuration-wise, this is our home device settings page here. And you'll see there's a lot of little drop-downs there in the middle. And as we click through each one, we get our settings. But this is accessed through a simple web browser. We hit the IP address, and this is where we're at. When we click our TCP IP settings, we get a chance to go ahead and just set up the device's IP settings like we would with any network online device. The next set of settings that we can go to is our Modbus configuration. This is our Modbus RTU settings page. Just like we'd expect, I can go ahead and I can set up my byte orders, I can set up my parity for the serial configuration, and I can schedule the polling. And if I'm not setting up RTU, I can set up Modbus TCP. And here, it's just a chance for me to set up my byte orders and the poll scheduler. Once I've got those set up, now what I have to do is put my BACnet IP network settings in. So I go ahead and put in my UDP port, I give this a device ID, as well as a virtual network number if I would like, and at this point I'm ready to go up and running with BACnet. When it comes to actually adding the devices, that's done in our device management tab. And what you see here pictured is our device management tab. There's a drop down for RTU devices and TCP devices. For this demo, I'm going to use TCP devices, and they're not currently connected, so that's our red down status. But to add a new device, I simply click Add New Device. The window that pops up says, hey, how do you want to create this device? Another differentiating feature that we've got here is once I've set up one of these devices, I actually am allowed to export that device so that it creates a template, so that future installations of similar devices, I can start from the template. And that's what this window is prompting me for. It's basically asking, do you want to use a previously generated template or start entering those registers by hand? And that's what we're going to do here. I get my TCP device set up. I give it its object name on the BACnet side as well as its device instance number for its virtual device, and then I hit save. And now I see that it has been added to my network. On the next slide, we're going to see what it looks like to add the points. I select the device, and now it brings up my information, and I click Add New Points. And now I can go ahead and start filling in the Modbus addressing. So Modbus hasn't gotten any easier. We still have to go through and manually format each one of these registers and get it set up. The nice thing is, though, once I hit save, it is actually already taking care of not only bringing the Modbus point in, but it is also now exporting on the BACnet network. There's no additional steps. On the BACnet side, I can go through the BACnet device listing here. I find that TCP device we added, and there I can see that Modbus point that I brought in. It's already being broadcast as a virtual BACnet point. Once again, our little easy web interface picture here, some additional information that's on the screen that we didn't look at before. First of all, we told you that either 1,000 or 2,500 points. We've got a very simple gauge there on the left-hand side showing you exactly how many points are remaining of your license. So at any point during your installation, you know how much more you can get out of this device. Additionally, we have a home page and a help page as part of this. The help page has our user documentation and it'll help you as you're running into problems. The home page actually has essentially a step-by-step quick start guide. So if it's your first time installing this product, just start on the home page, and it's going to walk you step-by-step through adding your Modbus devices and exporting them out as BACnet. And with that, we will turn it over to our next presenter. Thank you.
Hi, I'm Travis Reno. I'm the Product Development Manager at LinkSpring, and I'm here to talk to you today about our BACnet to Haystack data pump. So what is this data pump? The data pump is a device that talks over industry standard BACnet protocol, either through MSTP or over IP or over Ethernet. It reads the information that your BACnet devices have to offer, and it exports all that information into a Haystack server. Today we support connection to the SkySpark server and to the Connex Haystack server. So who's this device for? It's for system integrators, people who want to get remote access to their customers' building data through their own Haystack server or through a partner's Haystack server. It's for building administrators who are responsible for their own building management. So this device will get the data from their BACnet network up to whatever management system they choose to use. And for software as a service providers who also need easy access to their customers' data. So you can put one of these devices at any of your customers' remote sites, and it will send their BACnet information up to your Haystack. So the advantages of the data pump over some other possible solutions, it's a single self-contained device. It's small, it's mountable, it's a single device that you can put anywhere, and it'll start immediately collecting that data. There is no licensing required, so there's no point licenses or other licenses involved. Once you have the data pump, you have everything you need to start collecting that information. And because there's no point licenses involved, it's a lower cost solution than other things that might do that same kind of work. It's easy to set up and configure. It will easily get your data from the edge directly into your enterprise system. There's a simple web page setup. You just need a browser, point it to the device, and you can do all the configuration that you need. And it's a set it and forget it kind of operation. So once you set this thing up, configure it to talk to your network, it will continue pumping that data then forever until it dies. So what we have here is the discovery page. We haven't shown you all, we're not going to show you all of the configuration items that we have for the data pump, but this is the discovery settings for the data pump. And you'll see there are basically three windows here. On the left is the discovery. So we'll click that discovery button, and the data pump will go out onto your BACnet network and discover all the BACnet devices there that respond to those discovery queries. And you can see in this case we've discovered one device that's called LYX30P, and then underneath that device we see the points that particular device supports. The bottom part of that panel, the database panel, shows those items that we have added to our data pump. And on the right-hand side, the Haystack panel, that shows the Haystack tree of items that we've discovered. So we have a site. Inside that site, we have devices, and inside the devices, we have points. We also have custom tagging that allows us to add whatever tags we want to these individual points, those tags that are supported by the Haystack protocol. And then you can pump those points with their tags and their values to your Haystack server, and it will do that at the intervals that you decide. In addition to sending live data or near live data to your Haystack server, the data pump also has 30 days of onboard storage. So if, for example, your Haystack server were to become unavailable or if SkySpark was down for some reason, the data pump will continue gathering information from your BACnet network, and it will store that information up to 30 days. And then once your SkySpark system becomes available again, it will send that information off to your Haystack. The device is highly configurable, so you can decide how frequently you want to collect data from your BACnet network and how frequently you want to send that data up to Haystack. Large number of configuration options in terms of what you, how often and how frequently you do those deliveries. The data pump is recommended for up to 250 devices and up to 5,000 points. Again, you don't need point licenses to use the data pump. There is an onboard Haystack server, so if you're interested in doing Haystack API calls, the data pump supports all of those Haystack options. And like I said, it fully supports Haystack tagging, so you can do any tagging that you choose, and it will send that information along.
Hello, everyone. This is Derek Metchie, and I'm one of the support technicians here at LinkSpring. And I would like to introduce you to the Onyx CE121 cellular router. This cellular router was designed for the purpose of connecting to remote TCP IP devices and networks where no outside access to the site is available. The Onyx supports a secure remote access to intelligent buildings, energy management systems, and machine-to-machine applications, all through the use of a 3G cellular wireless network. And it's built on top of the standard or our familiar Onyx platform, and again uses that 3G network, which is made possible through a secure VPN cellular network. This VPN is required to join that network, and LinkSpring actually provides the VPN application and the login credentials that are necessary to connect to the router remotely. All the necessary credentials and so forth that you'll be using for the VPN are set up at the time that you purchase the router. So any PC that needs to access the router itself or the devices that are downstream of that router remotely must have this VPN software installed. Now, the router comes with a standard Ethernet port to allow local connections directly through the router without the VPN. You can plug right into it, or if you're on the local network, you can access it through an IP address that you'll assign. Again, it's on the familiar Onyx platform, so this, if you've got some of those other products that we've talked about, these interfaces will look familiar to you. The USB port that is shown here is available mostly for troubleshooting purposes when necessary, if for some reason you can't access the router through the Ethernet connection. So configuration of the router involves assigning essentially custom ports that correspond to the specific ports that are required by the downstream devices, therefore creating a port forwarding environment which allows you to access and configure and troubleshoot those downstream devices remotely. So the router is configured completely through a web interface. The look and feel is very similar to our other Onyx products. You access it through a standard web browser with only a few menus to navigate through the setup of the router. After you log into the router, the TCP IP settings shown here are likely to be your first stop. This is where you are going to configure the device IP and the subnet mask and gateway for the local network that the router is going to reside on. The bottom couple of portions there actually represent the IP address and the DNS addresses that are assigned by the cellular service. So you probably won't have to manipulate those, but the top two the top fields there, you'll want to assign to whatever IP address matches that of the local network. The next tab here is the Define Routes page. This is where you create the custom routes and ports that the router is going to use to forward the incoming connections down to the subordinate devices on the network. Here we show 3 routes defined for the same device, but to different ports of that device. Each port or route directs the incoming data transmission to the specific interface on that device. This happens to be a Niagara system configured to allow access on ports 80, 1911, and 3011. Accessing that end device through the router first requires that you establish your connection to that cellular VPN network on your PC using the VPN application and credentials provided by LinkSpring. And then once that VPN connection is made, you then enter the IP address of the router in the appropriate field of your application, along with the corresponding WAN IP address that is assigned to the that is assigned in the defined routes section shown here. So when the router receives the incoming transmission, it will then forward that data to the corresponding LAN port of the downstream device, thereby establishing the link to that device, allowing you to proceed with your work in the normal way, just like you would as if you were connected to it directly. And just like on our other Onyx products, the Cell Router has an integrated help menu here. So if this is your first time using it, you can go to the help menu, and because of its simple setup, it does go through and clarifies how to add routes and how to set some of the configurations for the router. So the next screen here actually shows the interface to the website where the VPN software is obtained. You'll get this information when you order your router, but shown here, you simply enter the username and password and select Connect, and it will prompt you to install the VPN application onto your local computer. So from after that first initial download of the application, this is the window that you would see anytime you go to initiate the VPN. You enter the same username and password in the fields to establish the connection, and then once your connection is established, you go to your application. In this case, we're just using a standard browser to access a Niagara web page. And what we see here is the login prompt for the web interface of the system. But you'll notice in the URL section of the browser, we entered the IP address of the router followed by a colon, and then the port used for the HTTP connection, which in this case was port 8080.
Well, thanks to all the presenters. That concludes our webinar for today. Just to sum up again, edge devices are indeed on the front line of our buildings and are adding value to our traditional building systems, and truly are contributing to a new shift in the way we connect, process information, make decisions, and how we manage and operate our buildings and facilities. We hope you've gained more insight into some of the ways here that we at LinkSpring are meeting the edge. Again, on behalf of all my colleagues here and my teammates, I'd like to thank you again for joining us. We'll be providing you a link where you'll be able to access today's presentations. If you have any questions or would like additional information and further discussions, please contact us at marketing@linkspring.com. Thank you.